So, how good is this? You're not afraid of anything being complicated. In fact, you're now going to turn something very simple into something more complicated and then break it down and get to the solution. I think that's got to be feeling pretty good about your ability to handle math situations, especially when you think about that you're actually making them more complicated. You're not afraid of that. You know that even when it's complicated, you will be able to match it up with something, and through that you will be able to move forward with the solution. So I think it's very interesting. We rarely make things more complicated in order to solve them, but this is a situation where we are. And feel good about that, because what it's actually saying is, no matter how difficult something is, I'll be able to find a way to actually move through it. And what you'll actually probably realise is the really simple basic stuff sometimes are the harder questions. So, okay, you might have something like this. Step 1, compare the combination and sign of cos in the given equation that you have to solve. So if we've got this situation, root 3 cos A minus sin A, which would be, say, the left-hand side of the equation that we're solving. If you've got something like that, you're matching it up. What is the match? Now, we don't want to be stressing ourselves out, going, I don't know these. Use the reference sheet. Plus, however, the reference sheet doesn't have the R in it, so maybe on your reference sheet for these early questions, you add, well, it doesn't actually have the minus situation for sine, and it doesn't have R introduced into it. So write all of that on your reference sheet. Write it on there, and hopefully you will get to the stage where you don't need to look back at the reference sheet at it. But if you always do, and the first step you do when you get into an exam or an assessment task is to write the additional information on the reference sheet about these some identities, then do that, and then you'll have it there. So we're looking to see a match because we want in some ways to give us the option of complicating this with another angle called the auxiliary angle, but what that will do in the long run is reduce the trig ratio to just one trig ratio. So in this case, what do you see? Cos and a cos. So we're starting with a cos, we've got a minus, and we've got sine of that same angle. Hopefully you can see that, yes, it is a match with R cos A plus B. That one's on the reference sheet. Once the match is found, compare them with the intention of identifying equivalent parts. So what does this original root 3 line up with now in what I'm going to replace it with or match it with? Hopefully you can see, well, there's your cos A and there's your cos A. What have we got left over? In here we've got left over root 3, and that's got to match R cos B. So R cos B equals root 3. Minus and a minus, the signs are really important. Sine of A is there. And what have we got left? We've got R and sine B, but what's here that we don't see? Hopefully you can see that's a 1. There would be a 1 sitting there, and not a minus 1, because the minus is taken into account here, so it's a single 1. So as we said, we're going to complicate it. We've introduced the r and we've introduced the b, which is the auxiliary angle, and we don't know what they are at this stage. So we must find their values. I just realised I don't think I ever gave you the complete equation, but we can see it coming out now. Remember, our aim is to replace root 3 cos A minus sin A, which is the only part of the equation I've given you so far. And we're going to replace it ultimately with r cos A and B, but we're going to have a number in the r position and an angle in the B position. So our new equation to solve becomes this left-hand side now goes from that format into this format. And what I've never told you is, like I said, the whole equation. So it was solve the equation, root 3 cos A minus sin A is equal to a half. That would have been the entire equation. Just in case you're wondering where that half came from. It was just that I never ever stated what the entire equation was. So, and we know we can't solve that. We've got to have an equation before we can solve anything. An equation has an equal sign in it and a number on the other side. So r and b will be replaced eventually with numbers, and then you can see we've solved those sorts of equations before. We might have called it a compound angle. It's a simple cos equaling a number. So we will have taken something difficult in its simplicity, turned it into something more complex because we've added an r and an auxiliary angle, found those values, put them back in here, and then end up solving a nice trig equation. The process to find r and v usually involves constructing a right angle triangle and using Pythagoras' theorem. So that's not too difficult. Sometimes you'll need to go to your calculator to find the size of an angle. The numbers might be really awful. And you must be prepared that this step will be different from question to question. Whatever process is used, the aim is to establish the values, the numbers for r and b. So, now, using this instruction here that it involves constructing a right angle triangle, we had that r cos b was the root 3. We got that from matching up the bits. And we had that r sin b was 1. Now, all I've done is divided both sides by r to give me the expression for cos of b. Cos of this angle is root 3 on r. So I draw my right angle triangle. My understanding of cos is adjacent over hypotenuse. I'm putting b here. Adjacent is root 3, hypotenuse is r. We know in that same triangle, because we're talking about angle b, that the sine of b has to be 1 on r. Sine is opposite over hypotenuse 1 on r. Some of you will recognise that triangle, and you will know that this is the 1, 2 root 3 triangle, or if not, you will use Pythagoras' theorem. Square that, you get 3, square that, you get 1. Add those two together and take the square root of 4, which is 2. So we know then b is equal to, this is our pi on 6. We don't need to go to the calculator, but keep in mind there are times when we will. So we have found the auxiliary angle. And the value of r. Now, this step here is not difficult. It's either Pythagoras and the special triangles and angles, or it's Pythagoras and the calculator. So our new equation is now, we can replace all of that was on the left-hand side with 2 for r cos a plus pi on 6 is equal to a half. You've solved equations like that previously. So I'm solving 2 cos a plus pi on 6 is a half. I've divided both sides by 2. And cos of a plus pi on 6 is a quarter. This is a compound angle. Let u be your a plus pi on 6. And solve cos of u is a quarter. U is cos inverse of a quarter. Now, that didn't turn out very nice. So we have to go to my calculator, as you can see here. And I've made sure my calculator is in radians because I'm going to be adding on part of an angle that's measured in radians. So we've got the cos inverse of a quarter is 1.318. So from the calculator we had u is 1.318. Last step, let's get back to solving what was the variable in the original equation, but we will use u is 1.318, but u actually represents, and I can replace it with a plus pi on 6, it's 1.38, and if I go to my calculator 1.318 minus pi on 6 is 0.79. Let's call that a is equal to 0.8 radians. To 1 dp. And there we have our answer. I'll stop the video. You can try this. It says you try solving this. See if you can have a go of that and then have a look at the video where I will write up the solution.